Hey Michele, hi Roberto. Ah, okay, good. Uh, Good question. How do we find out? We go on the Morrissey platform, we look in the chat. Ah, go to stage. We can just go to stage. I can. Ah, yeah, we can go to stage. I guess now it's a button above people. Oh, Q&A. Do you see the Q&A tab? Yeah, above them, on the toolbar above them. You don't have go to stage. Do I? Keynote Singularity. Okay, I'll try to go to stage and see if that brings you to, but that doesn't make sense. I think you should have a button for go to stage, but let's try. Okay, it did not take you to stage, but let me send you a screenshot so you see where I see the button. Screenshot coming over to Skype. No, I don't hear you, Michele. Is it? You're muted here on the platform. Yeah. Now. Ah, maybe try to find the email. Yeah. There should be a backstage link for your session entitled Keynote. Wow. I think we should chat with whomever is. We should email them. Mm, let's see. Let me go to the other. I think I'll go to the other session and try to type it in that chat. Maybe they are looking there. Yeah. It is. I mean, you clicked on that link and then it brought both of us here. It has to be this. Okay, so we are live streaming, I guess. I'm Mircea Lungu. I'm associate professor at the IT University in Copenhagen, and it's my pleasure and honor to introduce, to chair the keynote session today. Let me start by providing a few important technical details about the broadcasting of the keynote, and then I'll introduce the speaker. So the technical details. The technical details are as follow. Due to technical difficulties, the keynote is going to be streamed live from YouTube. So the link to YouTube stream is already posted in the chat. After the introduction, you switch to YouTube. However, remember that the keynote there, after the keynote, there will be a question and answer session. And at any time during the presentation or during the follow-up discussion, if you figure out that you have a question that you want to ask to the keynote speaker, or anything that would require him to provide more details or provide an answer, ask it here in the Q&A on the Mircea platform, or just as well, ask it here, that's it. I'll keep an eye on all these questions and make sure that I read them out loud to Michele in the discussion session after. You will not be able to, you will not have audio. So you type it and I read them and I have a discussion with him at the end, okay? I think this is it about the special technical situation with the keynote. And then now to the speaker. If you've been part of the VISSOFT community, you surely know who Michele Lanza is. He was my PhD advisor. While I was thinking how to introduce Michele, I realized that in the bio that he had here on the platform, there was a key sentence that I think really is a good explanation on why I'm curious myself to see his keynote. And the sentence is, Professor Lanza's research interests are in software engineering, and his research passion is software visualization. So indeed, Michele has done a lot of work in software engineering, and ever since I met him, he was passionate about software visualization. I think the first time I met him, I was a visiting student finishing my master's thesis at the University of Bern, and he was a postdoc there. He was passionate about software visualization. Later, I did a PhD with him, and he was still passionate about software visualization. And nowadays, he is full professor at the University of Lugano. He is the director of the Software Institute in Lugano. And as far as I can tell, he's still passionate about software visualization. So I think he definitely, over all these years, he definitely had the opportunity to create a unique perspective on the field that represents the domain of focus of this conference. And although the title of his talk is Singularity, I still suspect that he's going to talk about his understanding and his perspective on, probably the past, present, and future of software visualization. But this is my assumption. So I think the only way to surely find out is to actually give the word to Michele. Also because I did try to, since the abstract of his talk is missing from the VISSOFT website, he is guarding the slides as well as Apple, so there have been no leaks. I don't have any inside information on the content of the slides. Thus, the safest way to find out what he has to say is to actually go and listen to him. So in order to do this, please go to the chat, click on the link there, and let's meet in the YouTube channel for the keynote. Thank you very much, and see you in a bit.
Ok, vedi un momento se... Can I see the streaming? Okay. Good afternoon, everyone. Good evening and good morning, wherever you are. I hope that everyone is on YouTube now and that it's working. Okay. and welcome. This is my keynote entitled Singularity. I would like to start with a little prologue. And the prologue essentially is about one message, and the message is that this is not really a keynote, okay? Because it's something that I realized while preparing this talk during the past months. Actually, I started already in February, March when I got the invitation, and then during the summer, instead of producing slides, I was just lying on the beach and thinking that something was not really correct with all of this. Because usually a keynote, I like giving keynotes, by me has to do with a lot of slide design, and then essentially having an audience in front of me, responding to the audience, also being, as far as I can, provocative, and usually pass some nice messages to people. And that's one of the slides that I usually use when it comes to beginning my keynotes. And then basically that gives me some kind of freedom to say whatever I want, and then there is this audience in front of me and people respond to it. And then based on the responses, I can basically adapt the way I talk. And all of this during the summer, I realized one thing, and that is that this is not a keynote. This really is just a monologue. I'm here in my office. I don't know whether the internet connection will drop. If it drops, then I will not even have some kind of signal. It doesn't make sense to crack jokes because you wouldn't get them, or no, I mean, you would get them, but you wouldn't respond in front of me, and I wouldn't know whether they work or not. It's really pretty sad, okay? It's due to the current situation. But overall, let's say that it's not a very nice setting to give a keynote. This is a monologue, okay? And in a way, you could say, well, what is this all about? Is this just going to be some silence? Canned silence? No, there is some structure to it. So the keynote, the talk has a structure, has 4 parts. The parts are called I am, we are, dying and killing, and the singularity. Or, if you want to rephrase this slightly, and this is actually also the abstract of the keynote, it's this one here. I am, and we are dying, and we are killing the singularity. So, who am I actually? You see, when Mircea said that Michele is well known in the community and so on, you realize that this is not always the case, that sometimes people come later on, or they're actually so young that they don't understand who you are. So I'll just provide you a little graphic in terms of who I am. So here you see all my publication output from 1999 to 2021, so this year. Each rectangle is a paper or some kind of scientific output, can also be a tool, demo, a report, a technical report, a preprint, and whatever you want. And all that you see in yellow is visualization work. So as you might notice, yes, I've done a lot of visualization work, but actually around 2016 it starts to peter out a little bit. And I was not very active in the last half decade, and now there has been a return of flame in 2021. The messages you should get here is that I've been around for a long time, so probably some people that are listening to me right now were not even born when I published my first paper. And yeah, I think I do know something about software visualization, or at least I can pretend to do so because I managed to publish. Another way to say who I am is this. I am Legion. I am a lot of people. If I look back at these last 23 years, I have worked with a dozen, actually more than a dozen PhD students, several dozens master students, several dozens bachelor students, and also had a lot of collaborators. And in a way, all of this work in the end has made me as a researcher and made me become who I am. So in a way, this is also a way to say thank you to those people, because without them I wouldn't be what I am right now. So it's also their fault. Okay. Another way to say it is this. I am legend. doesn't say I am a legend. So this is the title of a book by Richard Matheson. It's a beautiful book. Actually, it's a vampire story. There is a movie adaptation of this book with Will Smith as an actor. The movie sucks, although I like Will Smith, but the movie sucks. The book really is a vampire story where there is this person who goes out hunting vampires throughout the book. And at the very end of the book, all the vampires assemble around his house, and then one vampire starts to speak, something that they have never done during the whole book, and says, look man, stop killing us, because you're the only one who's not a vampire. And this puts things in perspective. As I get less young, as I do more work, I've seen also the whole software engineering / visualization research scene change over the many years. And it has moved into a place nowadays where I don't feel at ease anymore, really. And it has become more and more difficult to actually publish the stuff that I want. The second part is we are, because in a way I am part of a research community, the software visualization community, but I'm also part of some other communities, like the mining community and so on. And in general, I believe that there's a bunch of fundamental things that are not completely correct to the software visualization community and software engineering at large. The first one is this one here, that this, like Weinberg said in 1971, programming is a kind of writing. So when people write software, write source code, what they do when they program, they actually write. So it's a typing activity. And I maintain, and I already said this in a bunch of my keynotes in the past 11 years, is that this actually is a wrong way to conceive things. Because it also leads to another phenomenon that I'm struggling with. And that is that you have software visualization as a field, and software visualization is considered as a subfield of information visualization, where you take information, and in this case it's software related, and you visualize it. Now, if you adhere to this principle, what happens is that you end up having a process, a research process, which looks like this. That you have on the left side, you have software, Git repos, repositories, projects. Okay, software. You mine that software, you dump it usually in some kind of a database just to scale up the analysis a little bit, and then you visualize the data that's in the database. And this leads to a bunch of charts, and based on those charts you can write a paper, and this is the end of the story. And this, I think, applies for 80% of the research works I've seen, at least in the last 10 years. It has become a de facto standard. Okay. Now, you see, the first problem there is that when you do research in visualization, there's a bunch of things that, and I've seen that in younger people especially, or in the community at large, is that you have to know, okay? Especially with respect to how information, especially numerical or quantitative information, can be displayed. There are ways to do it the right way, and there are ways to do it the wrong way. Let me just quickly show you an example. You see, people who want to do research in information visualization and software visualization, they have to read this. And I've seen that a lot of people didn't. And Tufte, who is the author of this book and a bunch of other books, they have never really read them. There's actually even better books. Let me show you another one, which is this one here by Steve Few, called Now You See It. There's another one called Show Me the Numbers. These are all books that are absolutely necessary if you want to do research in visualization. Actually, the Bible for me is this one here by Jacques Bertin. I have the German edition, but this book, written in the 60s, so 1960s, is just an amazing piece of work. And if you want to do research in all of this, in soft visualization, information visualization, this book can really change your life, okay? So in a way, this is all about basics. And that's one thing that people have to start to get right for real, okay? But all of this, in a way, leads to the way that you can visualize information about software. You don't really visualize software itself. You visualize information about software, like metric information, any kind of other meta information that you can mine. And before I said programming is writing, and I maintain that programming is not writing. When you create software, you do something else happens in your mind. And in a way, this goes back a little bit to changing the point of view. Okay? This is a sentence said by Galileo Galilei when the Vatican forced him to say that the sun was moving around the earth, which is a geocentric point of view or worldview. And Galileo discovered that actually it's not true, that the correct way to look at the world would be a heliocentric one, where the sun is in the middle, okay? Which means that you completely shift perspective. And the perspective I'm talking about is when you actually visualize software itself, okay? Where the visualization and the software cannot be distinguished anymore from each other. And then this means that what you have as a primitive process gets extended into a much more complex process, because the mining is still there. Obviously you have to mine stuff, and usually there you deal with scale problems. You have to process a lot of data. But once you have a database which contains the data that you want to analyze and visualize, what you need to do is to use your brain and model that information to create an actual first-class model of the data that you have. And then you visualize that model. And that model then can be interacted with. And this means also that there's a feedback loop, that then you can interact with the stuff, think about it, refine the model, refine the database, and refine actually at the last stage what software itself is. So this is really changing completely the point of view. And I guess you might have guessed by now that this is the singularity I'm talking about. To make it short, programming is not writing. And as long as you believe that programming is writing, then obviously all of this will not make sense to you. Okay? But before we get there are some observations that I have to make about research in general. Okay? This part is called dying and killing. And the things I'm going to say, I phrase them as haikus because I had nothing better to do. So let's start with the first one, which says, being academic, science is such a flower with a pandemic. You see, one thing that you notice when you do research for decades, like I have, is that eventually I'm not saying you grow tired of that game, but you start to understand that all this rushing for publishing is actually not meaningless, but it doesn't make a lot of sense. There were actually already many things that were broken in the system before the pandemic. And then the pandemic really exposed them. Because before the pandemic, yes, we did go to conferences, yes, we did meet people, but often you were sitting around in sessions where somebody was speaking something in front, big room, 5 people, nobody's listening, people are checking emails, and the impact was never really there. Okay, so the goal of the game really was to get the paper out. Even presentations were not considered so important. And with time, this became this rinse and repeat process where you would just go from one paper to the next, to the next, to the next, and you would have your deadlines, the important ones in the year, and you would rush towards them, would maybe get a paper accepted at ICSI, and then 9 months later you go and you present, and then that paper essentially is put into some virtual drawer, and you go on to the next thing. The pandemic has put all of this really in a questionable light. The question really is, what are we doing here? I mean, is this what you're witnessing right now? Is this a conference? I don't even see anyone. There's only Roberto here who's managing the super complicated setup, but nothing else. It's really frustrating. I mean, if this was the Middle Age, imagine that in the Middle Age, I'm standing in front of this bright window and I'm talking to myself. I would be burned at stake. Okay, it's really weird if you think about it. So there's something wrong, and I think that we also have the wrong goals in the meantime. This actually has been even being strengthened by things like CS rankings and this rush for citations and the H index and so on, which really has become the goal. Okay, and this is wrong, because what this is really all about is research, that we explore things that nobody has explored before, and that there is no guarantee that what you do actually makes a lot of sense. If I look at the papers nowadays, most papers at ICSI and also MSR, which is a community I like a lot, it's always a small idea and a huge validation. But if you look at the paper as an end result, the idea is and remains small, and the rest is just technicalities. Okay, this has even been furthered now with things like empirical standards and so on, which are perfectly fine. But I believe that we are killing really the innovative part of research here. Speaking of that, this haiku here says, VISSOFT was before, Softless silently killed it, time for a rebirth. Now, I was still there. I was actually at the same time VISSOFT and Softless steering committee member. And back in roughly 15 years ago, we had a discussion. So basically there was Softless, which was driven by ACM, and it was a real conference. It was a symposium, but it was real, like with full-blown proceedings, the papers were longer and so on. And there was VISSOFT, which was some kind of clown, because you could present whatever you wanted, but it was a very funny event. And then at one moment, the two steering committees proposed, because more people were going towards VISSOFT instead of Softless, they proposed to merge the two. And actually out of that then VISSOFT was born, which in the meantime has become an international conference. But I think what has gone wrong in this procedure is that VISSOFT has abandoned the playful nature that it had and is trying desperately to become serious. As in, if you want to submit a full paper to VISSOFT, then you need a full-blown validation, meaning, and in our case, soft visualization, it means running an experiment with human subjects, with enough human subjects that it actually makes sense. For anyone who's ever done such an experiment, you know that the experiments are very questionable and fragile in terms of what you can conclude out of them. And in general, the effort is so big that, think about it, if you would really spend months to do an evaluation with human subjects and you end up having good results, would you submit that paper to VISSOFT or to ICSI? Okay, and I guess you know the answer. You would probably more aim for the big ones. The problem is that the big ones, the wide ones, they don't understand really the problems that visualization is really about. Just a brief example, one of the papers that we are presenting today with David, it's a collaboration with Jesus and David from Madrid, features a full-blown evaluation with virtual reality. And we submitted that before to ICSME, and we got destroyed, okay? And most of the destruction happened through a simple sentence, which said, I don't know what this is about. I don't think that this is relevant to something like ICSME. You see, there's a problem there, okay? It's a cultural problem. In general, the thing with aiming for ICSI is a problem, because anyone who's ever really done an evaluation with human subjects will know that this is comes with so many threats that whatever you actually are trying to prove usually cannot be proven. The threats to validity never go away. So, in general, I believe that people should go back to VISSOFT and not aim for ICSI. And anyway, a good reason to stay with VISSOFT is that VISSOFT at least doesn't use double-blind. And double-blind was yet another stepping stone towards hell for visualization work. Because visualization research in general is incremental, where you build on top of each other. Running a survey with a bunch of developers and then encoding the results of those surveys and writing up a paper is not incremental research. That's a self-contained entity. And that's why it's easy to submit to ICSI, MSR, FSC, and all the others. For VISSOFT, you are building basically, you are investing in building the tooling that you need to keep growing. Okay? So when it comes to double-blind, although I appreciate a lot the general thought behind it, which is to try to ensure fairness, and hence my sentence, when it comes to reviewing, just don't be a dick, okay? That's all there is. And have an open mind. Of course, that's a rule that is hard to maintain, but in general, double-blind is harming research. It really is. Yes, the system is a little bit fairer, but it's killing incremental research, which is the definition of software engineering research. It's incremental, okay? The rest is just surveys. And going further in this direction, visualization is really about research and development, and tooling is the key. And there's too many works I've seen recently in the last 8 years or so in the VISSOFT community where people don't build their own tools anymore, they just reuse other tools. Or they use general frameworks. I'll come to that point too. So it's worth investing into this. If I would have to make a profile of a good software visualization PhD student, first property would be exceptional coding skills. That's what this is really about. It's not about data analysis skills. That's secondary. It can be learned anyway. Coding, you're good or you're not. Another example, I think it's bad, it's a really bad decision that VISSOFT and SCAM are completely in parallel, because they are really sister conferences. And in general, if I look at the things that lead or should lead to visualization, that's essentially the part of SCAM. Okay? And SCAM is de facto now the only conference left where you can really submit work about how you can analyze software. In conjunction with that, it's not only about parsing, which nowadays has also been solved by using standard frameworks, it's about modeling. That's what you really have to do to make things first class. And that's why SCAM and VISSOFT, they should be like this and not overlapped. And last minor point, but it's actually a big point. Many visualization works that I've seen in the last 8 years or so, they use as an output general visualization frameworks like D3 or something, or FreeJS, something like that. Now, these frameworks are fine, very fine, if you want to visualize information about software, and you can actually visualize any kind of information, but at the same time, a framework produces a language in which you can express your thoughts, and the framework produces a limited language. The language is limited. You can only do what the framework allows you to do, and not more. And what happens is that then you don't try to extend the framework, you basically try to work within the boundaries that are set by the framework. And 20 years ago, this was kind of different. There were no frameworks around, so you would build frameworks. Okay? Just a simple example, our work on Code City, done by Richard Vettel 15 years ago. We started 15 years ago. He used a framework called June, which was a framework which was sitting on top of the OpenGL specification. So it provided just the necessary abstractions. So for example, create a cube, on which you could build stuff. It wouldn't deliver to you full-blown visualizations or full-blown charts. Those you have to construct yourself. Nowadays, also because of laziness, pressure, you have to publish, you go with the free or you feed it into R and then you get your charts and that's good enough. But that's not visualization, this is just charting. Okay. Now comes the part where you will probably go, whoa, the first part was strange, but the second part was even stranger. Okay. What about trying to reimagine this whole thing? Okay. Like we forget all of this, and that's why we need a whiteboard now. So, first part is tabula rasa, okay? And with that I mean, for a moment, forget about publishing, your H index, your best way to write up a paper, how you can conduct a qualitative, quantitative research, and all of that. Just forget all of that, and we just start from scratch. So what you really need is, you need to forget. Okay, just forget. And let's start. First, we start with culture. That's one aspect I've seen missing more and more, because I get less young, but the PhD students and the master students that I work with, they always have the same age. It's some weird time phenomenon, which really means that they don't read the right stuff anymore. They don't have a culture, okay? And a culture, for example, is the one of cyberpunk. That's, for example, something that really influenced me a lot. And I'm talking here about the age before I was even a student. It would just create some forma mentis, some way to look at the world or to imagine future worlds, how it could be. There, my suggestion, which is probably the first useful item on this blah blah that I'm doing here, is 3 books that I really think that every serious computer scientist should read in his or her life. That's William Gibson, called Neuromancer, Neil Stephenson with Snow Crash, and John Brunner, The Shockwave Rider. In a way, you can say that Gibson provides height, Stephenson provides width, and Brunner provides depth. Okay. I don't think I can convince you to read those books. I'm just saying that these usually are so important, so important. Another part of the culture, and here I just put Res as an example, is games are a sort of inspiration. If you know games like Res, Portal, Half-Life, and so on, they can influence you a lot, okay? Because they provide views into other worlds. Some games, for example, where they use procedural programming, they are so much more advanced. And actually there, they also touch upon a field that in soft visualization is often discounted, and that is the one of graphics. Because when you visualize, you do something with computer graphics, but the frameworks that are often used, they just try to obscure the fact that there's a whole layer on graphics. And some researchers who also have an education in real graphics, they can provide and create much more interesting visualizations. Okay. Also because in general then you end up having questions of scale that can be tackled with such approaches. And we go again back to perception. So the books that I showed before by Bertin and by Tufte and by Few and, for example, by Lima, there's so many books. I mean, look at this. Isn't this cool? Okay. These are the books that you should have a look at. And maybe they can provide some inspiration. Something that goes beyond the let's feed some stuff into R and get a bar chart or a pie chart, or if we are fancy, we make a violin chart. Okay, it's not about that. Here I put another word which probably some of you might not know. I'm not sure if you ever heard of the demo scene. The demo scene was born roughly in the 80s, and this is a worldwide movement which create exceptional pieces of art in real-time graphics combined with music. You should just go on YouTube if you have the chance, once 5 minutes, and you say demo scene 2020 or demo scene 2021, and you will see what I mean. These people can pack incredible pieces of art into very small spaces. They have extra tracks at those competitions for 64 kilobyte, 4 kilobyte, and so on. And then there's also the ones that have no limit, and these are full-blown pieces of art. Okay, so have a look at that. If you want to entice a PhD student, a master student to work with you on visualization, if you're a senior person, show them that and say, like, have a look, and maybe something goes click. Another part is, so let's get concrete. Okay, so everything is white, and we have here a representation, something, whatever it is. Okay, yes, it might look like Code City, it might look like any other city. There's a bunch of interesting approaches, for example, by the guys in New Zealand, where they used landscapes. Adrian Kuhn made things with islands and so on. Leverens made super interesting stuff. So there is something here in the middle, okay, that is, I'm not sure how it has to look like. Yes, I could have shown you now a slide of Code City, but I guess you know how it looks. And Code City is still far from what I have in mind, okay? But very important, when you do something like this, reification is key. Now, reification, which is a weird word, essentially is about making the non-concrete concrete. That's what reification is all about. So you make things first-class citizens. As in everything in here, whether it's a class, a package, a method, a person, a version, and so on, deserves to be a first-class object in your system. What is the alternative to that? Well, that's what MSR basically does. Most MSR approaches. They have their repo on the left side, then they mine the stuff, and they unleash whatever they unleash on essentially text. Okay? If at all, maybe they have a notion of what a file is or what a directory is, but it doesn't go much further. Now, obviously, if you want to reify the information here in the middle, this also goes back to the point of modeling. And this goes back to the point of the scan community. Because something has gone lost in the last 10 years or so, where we used to spend a lot of time reasoning about how you could analyze software and produce fully reified models of a software system. And this somehow now has gone lost. Okay. When it comes to modeling this thing, the underlying structure, in my opinion, has to be a hypergraph. Meaning, yes, like in computer science, everything is a graph. In this case, it's a hypergraph. So there are nodes, because everything here can be a node, and there are edges, which are the relationships. The nodes can contain nodes, the nodes are related to other nodes, and they are related to them through many different types of explicit and implicit relationships, and hence the term hypergraph. Once you have such a base representation of a hypergraph, you end up having also a problem of scale, because yes, object-oriented programming is nice, but if you would have every node and every edge in such a system, and now let's think that this is a concrete repository on GitHub, so you not only have the system, but you have all the versions, you would then end up having millions or tens of millions of objects, and that obviously doesn't scale. Okay, so the scale problem is both on the modeling mining side, but it's also then later on, we'll come to that, on the visualization side as well. So this means that once you have an underlying representation here, which is nothing but how things are related to each other, and that's a graph, then you can start optimizing this. Okay, for example, you could encode that using bitmaps or something like that, which is all possible. Problem is that nowadays nobody does that anymore, because it's easier to mine and publish. Another thing also is that these entities, which are also these entities here, they have many ways, or they should have many ways to visually express themselves. This term is called glyph, okay, where a simple glyph can be a rectangle, but actually it can go much further. I can give you a very nice example from a couple of years ago by Fabian Beck. These are so-called software feathers. So what you see here is classes, so each feather is a class. They did all the modeling and analyzing and analysis that is necessary to produce glyphs which are completely individual with respect to what the class is. And the glyphs, obviously, they are generated. So you can then just tell a class, show me your feather. And a glyph, like a feather, as you see, they are distinguishable. There are differences, which means there are different types of classes in the system. Okay? Another problem that the community in general has, but actually this applies to the complete computer science community too, is that we are still locked in a stage where GraphViz is the de facto standard to use layouts. The problem is that in general, layouts don't scale when you analyze big software systems or several versions of a software system. Try for a sec to use a force embedded layout on something like a single system, and you will see that this doesn't work. What you really need is a semantic layout, something which takes into account the underlying hypergraph in terms of what these things are and what the edges are and so on. And this of course then leads back to reification. But you look at the visualization community, and we still essentially use as de facto standard a library, which is a very nice library, but it was created 40 years ago. Maybe there's time for a change. Then the question is also, okay, imagine that yes, you have something like this, which can be some kind of cuboid, or if you want in 2D, it could also be some simple rectangle. Okay, this is a class, or this is a class. Now obviously a class is more complicated than that. Think back to the feathers. Although the feathers, they are just glyphs to visualize the class from a distance. Now I'm talking about how can we visualize the internals of a class. It's funny because actually probably the best work I've ever done when I was a PhD student was to work on class blueprints, where I would subdivide a class into layers and lay out the things that were contained in the class according to a number of rules, and the whole thing was augmented by meta information that came through software analysis, okay, like whether a method is overriding or extending or abstract or constant and so on. Speaking of culture, I'm pretty sure that many students nowadays, they probably don't know the difference between an overriding method and an extending method. It's simply because it looks like the parsing problem has been solved, so we don't deal with that anymore. But it's not true. Right now, the de facto standard, if you want to do some deeper analysis, in our community at least, is SourceML. Super nice tool by Maletic and Colored. But all the others have slowly died out. Okay? So there's a lot of potential there. Then there's another point too. Of course you can visualize a class like a blueprint, and the question then becomes, yeah, what are you talking about? That we never see code? And that's not true. When you get to the level of behavioral units, like a method, and the code describes the behavior of the method, that's when nothing works except the code. So at one moment you have to start visualizing code as text, but only at that level. And in fact, if you look at all the visualization works that have been done to try to visualize the source code at sub-method level with using glyphs or something like this, they simply don't scale. And plus they provide a level of unnecessary indirection, as in the visualization of the thing is more complex than the thing. So you might as well drop the visualization out of the equation and just look at the thing. And this works only for sub-method level. Okay? If it's above that, then obviously you end up having a different scale problem. So for example, if you look at the source code of a complete class in a primitive IDE like Eclipse or Visual Studio Code, you still have these hundreds of lines of code which don't fit the screen, which means something is wrong there. So you need another approach there. Then another question is, okay, imagine that you have this system. So now seen from above, this is your system. And the question is this your system? Where does the system stop, right? Because if you look at modern systems nowadays, a lot of them use APIs and libraries and external frameworks and so on. And are they part of the system or not? And that's not completely clear. Obviously you could say, okay, this is Spring Boot and this is a Java project and it's attached to it. But that also doesn't really work. You see, there's some work is needed here because often the reality, if this was Spring Boot and this was the system, is more that this is the system and this is Spring Boot. Spring Boot actually is much, much larger, but you only reuse small parts of it. So we have to find a good way to depict how these huge things below only touch the system to a little extent. Going further on this, so imagine that you do have a system. There's all this corona of, no, it's not COVID-19, corona of data and information that is lying around. So you have unit tests, and you have documentation, and you have forums, and you have mailing lists, and you have Discord servers, and Slacks, and plenty of other issues. Plenty of other information that is not in the system, but it lives around the system. Clumsily, we call this, in one of the infamous Barbados workshops, we call this a documentation landscape, which makes it sound really boring. I prefer to call it a corona, which, as a matter of fact, also evolves. So this thing that sits in the middle keeps evolving, because people are evolving it, but this thing around, which from a quantitative point of view is much, much larger and is very largely unstructured because it's humans doing stuff, also evolves and keeps changing. And for example, if the system changes now from framework A to framework B, it means that a part of the documentation landscape crumbles and another part is put up. So all of this right now, we still don't have a good way to connect it. We did some works, for example, with Alberto Bacchelli, where we investigated more than 10 years ago how people were talking about software systems in mailing lists. Back when mailing lists were still popular. Nowadays, nobody does that anymore. And that was interesting because suddenly you can connect at least to a part, a space, and connect the two things. So you could ask then a class, are there any emails that pertain to you? And you could also ask the model of an email, which parts of the system are you talking about? So super useful stuff. I have to speed up, I guess. Then there's also a problem of what I call the outside problem, that we also want to visualize the system at the higher level of abstraction. Usually it's called the architectural level. And there we also, so far, short of using the notion of packages that contain packages, or in the case of file systems, directories that contain directories, we haven't gone very far. This is not really architecture there, right? So something is missing there. Then, very briefly, data. Where is the data? Because data is actually what makes a system valuable. But databases, they are invisible. They're not part of the software system. You can infer them somehow through the source code that have attached to a database, but you'd never see the database. And we never spent much time investigating that. And also, even with the exception of Anthony Cleaver in this group. And also ad hoc repos that you find, for example, in JSON files or XML files, they have never really been studied how they connect to the system. On top of that, you add the evolution problem, because all of this, which applies for one version, you multiply with 100,000 versions of the same system. And then this means, again, scale problem, layout problem, information overload problem. Evolution just makes everything exponentially complex. Another part that we never investigated is sound. So you have this thing that you look at and you don't hear anything. It's like a mute movie from the 1920s. But the system is making noise because it lives and people are around it. We'll come to that. Then change. You see, current versioning systems, and the de facto standard has become Git, they compress changes between one commit and the other commit. Everything is smashed together and you don't understand what happens in between. So for that you should maybe look at the thesis of Romain Rob, okay, who did some work there and studied a better versioning system. On top of that, you have to add people, because all of this is not made by machines for machines. There's little people around here, communities, and they sit in the landscape and they sit around the system and they work all together, and we need to model that as well. Of course, there are some privacy issues there, but in general this is also largely unexplored and very, very promising. Overall then, this generates a gigantic scale problem when it comes to visualization as such. Frameworks that we have been using or we have been programming, yeah, sure, they work when you display 10,000 objects. They can work when you display 100,000 objects, but try to display 10 million objects or 100 million objects, which is the scale that we need, okay? And things fall apart, both from a model point of view and from a visualization point of view. So let alone ecosystems or mega repositories. We will never be able to do that as long as we don't tackle the scale problem. Then there's also another problem, which is the one of time. Time can be mapped on space or time. And when people map it on space, for example, horizontally, then this creates a timeline, right? And you can also map it on time, which creates basically an animation. But in reality, the time of a software system is not linear because it has considerable periods of inactivity. There is a rhythm to that, which are the days and the weeks and the months, a release schedule and so on. And that one also often is not considered. That's why you end up having, when someone displays the evolution of the system, you end up having something like that. And you say like, well, you know, this is because it was Christmas. But, well, you know it was Christmas. So maybe do something. Now, in this case, mapping time on space, do something about this. And if you map time on time and create an animation, then maybe invent something how you can fast forward or so on, okay? I could show you a little example here, but I'm going to skip that. Let's go quickly to 3D, because all of this, if possible, should be in 3D, okay? And you go like, why? 3D, what's up with that? 3D is really not about, what it really is about is the third dimension. It sounds stupid, I know. But it means that you have to exploit it fully, because what it offers on top of 2D is an up and down notion. So things are up and things are down. So for example, the paper that Susanna Ardigo is presenting this evening, in a couple of hours, uses the vertical space above the software system to display the databases. And then suddenly you add some semantics to all of that, okay? Then let's go to VR, and the real challenge there that we have done some experiments with the guys from Madrid is that largely unexplored, because this is all about how you navigate and interact with the stuff, largely unexplored. Then one thing which an architect of mine keeps banging me about this is that what is the unit of the visualization? What is one in such a space? As long as you don't define what one is, how big one is, okay, it's not clear what you're doing. Because for example, if you are in 3D and you create a visualization of a system which is as big as a table, then it means that you're a giant. If you create one where the city is as big as a mountain, then you are small, okay? So things change. And then on top of that, you have to add this thing that everything has to go live, because the systems are alive, okay? And display what they do while they do it. I know that this sounds all very weird, okay? So, I would like to close with two things. The first one is So in that sense, I would like to leave you now with this little final movie, and I would like to thank you. Bye. Wait, it's coming. Enjoy.
This was a triumph. I'm making a note here, huge success. It's hard to overstate my satisfaction. Aperture science. We do what we must because we can. For the good of all of us, except the ones who are dead. But there's no sense crying over every mistake. You just keep on trying till you run out of cake. And the science gets done and you make a neat gun for the people who are still alive. I'm not even angry. I'm being so sincere right now. Even though you broke my heart and killed me and tore me to pieces and threw every piece into a fire. As they burned, it hurt because I was so happy for you. Now these points of data make a beautiful line, and we're out of data, we're releasing on time. So I'm glad I got burned. Think of all the things we learned for the people who are still alive. Go ahead and leave me. I think I prefer to stay inside. Maybe you'll find someone else to help you. Maybe Black Mesa. That was a joke, haha, that chance. Anyway, this cake is great. It's so delicious and moist. Look at me still talking when there's science to do. When I look up there, it makes me glad I'm not you. I've experiments to run. There is research to be done on the people who are still alive. And believe me, I'm still alive. I'm doing science and I'm still alive. I feel fantastic and I'm still alive. While you're dying, I'll be still alive. And when you're dead, I will be still alive. Still alive. Still alive.
Mircea, are you there? Mircea, are you there?
I'm here. Can you hear me?
Yeah, I can.
Okay, let's hope that the people on the YouTube channel can also hear. So while you're talking, oi, 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 I can hear ourselves speaking from 5 seconds ago.
Yeah, you have to switch off Maurice.
Is it?
Yeah, you have to mute YouTube and then just listen to me.
Cool point, thanks. Okay, so while you're talking, we got some questions in from the audience. And the first question that I think I'll switch a little bit the order, because the first question was really nicely synced with your ending song. Because you're saying there's people on which the song was saying there are people on which we have to still do experiments, right? And I think Leonel is asking, what do you think is the role of user experience in the effectiveness of software visualizations? So should we care about user experience when we want to have something that's effective, I guess?
I guess the question there is, who are the users, right? And in this case, the users are, first of all, we who visualize. But if you want to propagate and make this bigger, if you want to create a singularity, then it's the average developer, right? So a lot of visualizations, they suffer from the simple fact that they don't scale, that they're too slow. I mean, I still remember when Ricky implemented CodeCity, and Ricky was an exceptional developer. CodeCity was really so successful only because it was very well written and highly optimized. And this nowadays is not really trendy anymore, because as soon as you have a least publishable unit, which is sufficient to get the paper out, you push the paper out and then you drop the work. So, and you don't invest anymore. So this really is, the answer essentially is yes, we have to invest much more into this. But it's not being paid back, okay? In general, don't expect any payback from all of this.
Okay. Thank you. The questions are flowing in, so I think we have to move to the next one. And although we'll be a little bit beyond the time, there's still now we are in the 15 minutes break, and people, given that it's a thing that happens at home, people can actually take a little bit of break and walk around. So we'll take a few more questions. Alex observes that he fully agrees with you that there's need for more work on visualization tooling. He also fully agrees that this is super challenging, and it's difficult because of implementation costs and multidisciplinarity. But he says this is also a problem present outside of the SoftVis community, for example, in InfoVis or visual analytics. Do you find something specific for the SoftVis community?
I guess one of the problems I see is that, again, there's no payback in building your own frameworks. It's much easier to reuse existing libraries to depict data, essentially. So if you want to be efficient, it's clear that it makes no sense to write tools, your own tools. And I agree that it not only applies to SoftVis and also not only InfoVis, it applies to the complete software engineering community. If you look at what happened to the tool demo tracks in the past 10 years, the tool demos, they have been pushed into a corner and they're not important anymore. They barely count anymore as a publication, which is really bad. So I don't have a good suggestion there, just probably doing is better than talking.
One thing, okay. I'll ask also a question of mine, and then we move on to some of the other questions in the forum. Given that I have the privilege to choose questions, I chose mine. So looking back at my own work in software visualization, it has been a little bit like you described, where you build a tool and then you write a paper, and then you move to the next tool and then you write another paper. And this is, we agree that it's time consuming. And then some years ago, I had this epiphany of thinking, but the tools that we build, they're research instruments, right? So it would be a little bit, if we just build a tool, write a paper and go home, it's a little bit like building an accelerator, like the people at CERN, right? They spend a lot of effort building an accelerator, but then they start doing research with the accelerator, and they use it and discover things with it, right? So that's a little bit another perspective where, okay, build a tool, but then make sure to write what you learn with it, and hopefully you can learn more than one paper, right? So is this an approach that you think would be valuable? And how would
I don't think that it's currently possible with the current culture of software engineering research. I mean, look at you, Mircea. When you wrote Software Note, which in my opinion was the best software architecture visualization tool on this planet when you did it. Okay, it was an amazing piece of work, and we wrote, I think, 2 or 3 papers on it, and then basically the ground was burned, and you couldn't anymore even try to publish on that. And one of the things that we should have done, but it's not supported in general by the culture there, is that you keep working using something like that, like a vehicle. The only thing where it works are ground layer frameworks. Something like SourceML, that for example, Maletic, Jonathan, and Mike Collard, they did the right thing. They just worked so much at the lower level, unseen by the others, but de facto they cannot publish on SourceML anymore. Maybe they can add an extension or something like this, but it has become the tool that many use to do stuff, which is probably the best thing you can expect from tooling, right?
Yeah. Fair enough. And I think maybe a little bit related to that, and maybe another, actually it's very related to that. Jesus observes that, or it asks, what do you think about the interoperability of tools? So maybe different teams could collaborate by focusing on some aspects of the problems presented,
Absolutely.
but still being able to use other pieces to complete something more complex.
Yeah, absolutely. I mean, I remember in the 20 years ago when we were working on the Moosry engineering environment, we spent a lot of work on an interchange format. Back then it was CDiff, then it became MSC, which was nothing but a precursor of JSON in some way. So at least right now there is this exchange format with JSON. It's very primitive, but I agree that it would be nice if a community could come together and exchange pieces, because what I described on the whiteboard, that can't be done in 5 years, and it can't be done by 5 people. That's a thing for the next 25 years by 100 people. And they need to work together. Unless a billionaire wants to give me 10 million, 10 million is enough. I think I can manage with 10 million.
Well, the video will be left online, I guess, so billionaires could still see it. Let's take a final question because time does fly. And I see that Fabian has a question here that I'll read for you. Michele, what do you think? How software visualization need to be different if the original systems were built using visual programming and modeling languages? So I guess the question is, do we need different visualizations based on the language or the paradigm that was used to create the original system, maybe?
I believe that the underlying representation, one of the hypergraph, will always work. But then you need to build on top of that. For example, I remember one experience where we analyzed a big COBOL system. And COBOL is not an object-oriented system. And then we had to do some weird mapping in terms of, okay, a section will be this in our object model, and a call or a line will be this in our object model. So that the hypergraph at the bottom, that one remains the same. And then what you build on top of it, that probably can be adapted given the various contexts that you have. That, I mean, in the end, everything in computer science is nothing but a graph, right?
Yeah. Okay. Unfortunately, time is up.
Yeah.
So,
Mircea, did you like it or not?
I think it was awesome. But actually, what we could do is we could also ask the audience, but we don't have any, not even virtual clapping. So I guess people can type in the chat feedback. They can click the like button.
Well,
like
you know, they can also,
subscribe.
if they want, they can also curse at me, which is also the other side of things. So, as I said, it was a monologue.
So I think it was one of the better monologues that I've seen in conferences yet. Thank you very much, Michele, for the keynote.
Thanks, man.
Thanks for the
everyone.
audience for sending questions, being here, for the monologue. And I guess now we start the conference. So in 5 sessions, the next session, 5 minutes, the next session starts. So see you in the corresponding sessions, people. And yeah.
See ya.